Hello, everyone. Welcome to to today's episode of DevStandup. Today we have the Ramu Murakami Gutierrez as our guest. Uh, Ramu is a product manager at Oracle, where she drives innovation in special and graph technologies. She is passionate about building intuitive and visually compelling solutions that help users to uncover insights from complex data. Before stepping into product management, Ramu worked as a solution engineer specializing in data management. Today, her topic is about knowledge graphs. The knowledge graphs offer a powerful way to model relationships, uncover patterns, and make data easy to explore. So, in this session, she will introduce the fundamentals of graph technology, then build towards these knowledge graphs where the data is enriched with meaning, context, and structure. So, before ado, let's explore it. So, Ramo, the floor is yours.
Awesome. Thank you so much, and thank you for having me here today. So, yes, we're going to be talking about graphs, and I'm going to give a quick introduction of what graphs are, since I'm not going to assume everyone knows about graphs, but we use graphs every single day, right? So let's answer the question, what is a graph? A graph is basically a graph model data. Basically, it maps data into entities and relationships, and it helps us understand and answer multiple questions. I think one of the most natural ways to understand graphs is through social networks. And for example, in here we have Ethan and Amelia. They're part of a social network. And if we wanted to answer the question, is Ethan connected to Amelia? We might think that they're not connected since they're not connected directly, but they are actually connected because they're connected indirectly, right? So Ethan is connected to Alex directly, but then Alex is connected to Henry, and then Henry is connected to Amelia. And that's how this indirect connection happens. We're also able to take a look at our data as a graph and answer other questions very quick. For example, who are the important entities in our graph or the important people in our network? And we could answer this question super quick, right? By just looking at our graph and identifying Alex and Amelia that are connected to multiple people in our graph, right? We also have Henry, that even though we might think that Henry's not that important, he's actually a very important person in our graph because he's kind of building the bridge between two different communities, right? So he might also be considered an important person in our graph. So we can take a look at other types of graphs, right? Which, for example, there's different industries using graphs for different purposes. And here we have an example of the manufacturing industry, where we have entities that are components and products, and then we have relationships that are basically this product contains this component, for example, right? And it helps us understand what would be the impact of maybe changing one component in our graph. So for example, if we were to change P underscore ID 185, how would that affect our graph as a whole? Or how would that affect our manufacturing process as a whole, right? I feel like we take for granted that maybe one screw won't make a change on other parts of our components or other parts of our manufacturing cycle, but a little screw can have a lot of impact in our manufacturing process. And then we have also the financial institutions using graphs, right? In this case, we might have entities as accounts, and then we have relationships as transfers or transactions, right? And one of the biggest focus on how graphs are being used in the transactions or financial industry is by understanding anomalous patterns, right? So One of them is a circular payment chain, right? Where, for example, money leaves from one account, it hops into another account, it hops again into another account, and somehow it ends in the original account. This is a way of understanding that there's an anomalous pattern happening here. And that's how we're able to detect fraud in the financial industry sector, right? When it comes to graphs. So graphs versus knowledge graphs, right? So my title in this presentation is knowledge graphs, and I want to talk to you, of course, about knowledge graphs, but it is important to understand graphs before we jump into knowledge graphs. And as we said just now, graphs are basically a way to model your data as entities and relationships. When it comes to knowledge graphs, they're basically real world concepts and connections between them. And in the AI world, everyone is talking about AI, right? We use these terms interchangeably. So basically, at Oracle and in general, right, you're able to store your knowledge graphs as property graphs and RDF graphs, right? And there's a couple of distinctions between both of these different ways of storing data as a graph, right? So we have property graphs that are simple and flexible. You're modeling entities like accounts, people, transactions, and then drawing those edges between them to capture the relationships, right? And these property graphs will hold properties itself, right? Like, for example, age, country they were born, etc., right? And the way they're connected. They will also hold properties. For example, this person met this other person at this certain time, etc., right? When you talk about RDF graphs, which stand for Resource Description Framework, it is built to capture more enriched, sophisticated semantics, meaning context, ontological relationships, etc. And think of it as a choice when your data needs to be following a specific format or structure, like in life science or regulatory compliance or enterprise knowledge management, where you need logical interference or inference. So here I have an example of a knowledge graph, right? And this graph shows basically the story of Einstein, right? And I really like this graph because everyone knows who Einstein is, right? We don't really have to focus on the domain, but we can focus on the structure, right? So in the center, we have Einstein, right? This is our center node or our entity. And radiating out from him, you see other relationships, like he developed the theory of relativity, or he contributed to quantum theory. He was born in Germany and he moved to Switzerland and he enrolled in, the Switzerland Federal or the Swiss Federal Polytechnic School, etc., right? But I want you to notice something else, which is the importance of relationships in here, right? So we have different colors for different relationships. The white edges are factual concepts, but the gold or yellow edges are basically different, right? They actually carry richer semantic meaning, like place, origin, movement. And in RDF graphs, you'd assign formal ontological meaning to those, right? So basically, the fact that he was born in Germany can give us more semantic meaning on the German culture. The fact that he moved to Switzerland can give us more enrichment in the Switzerland culture, etc. So here I'm just going back to the example, right, of property graphs versus knowledge graphs, right, and how they're different. So again, knowledge graphs can be created from property graphs, right? But we see how property graphs are a little more flexible compared to knowledge graphs that hold that semantic meaning, right? So let's talk a little bit about how knowledge graphs or graphs work in the Oracle database world, right? So I'm not sure if your listeners have any, if we have any database users, Oracle database users, but a lot of people are surprised to know that if you already use the Oracle database, you're able to use graphs, right? This is a native feature of the Oracle database. It's integrated, it's part of the Oracle Converge database, meaning that you're able to use vector search, you're able to use spatial data, relational tables, you're able to also combine it with JSON, etc. So it's pretty cool, right? When you create a knowledge graph from your relational tables at Oracle, you're actually not creating a copy of your data. You're actually creating a view as a table. And every time you insert, update, delete anything in that table, that is reflected already in your graph. And this is really important because let's say that we're trying to stop fraudulent transactions from happening in our account, right? We don't want this to take time. We want it to be in real time, right? So it's a key factor for sure. And we also use SQL syntax, which is amazing because it helps us basically leverage all of the functionality of SQL plus the functionality of graphs, right? So it makes it way easier for us to implement everything that the SQL syntax allows us to implement with graphs. So when it comes to creating a graph from data in tables, right? We normally, I think the most traditional way to store data is in tables, right? Even if we're storing data from documents, we end up storing it in tables. And I will be going over that, but let's continue with what we're covering right now, which is how to create a graph from data in tables. So as you can see here, we have two tables. We have one table with ID and name, and then we have another table that is showing something like a join, right? Something that's able to merge what we have on the left, right? So if we take a look, we're able to see how, for example, ID 1 is connected to ID 4, ID 3 is connected to ID 4 too. But in a very big table, this might be really hard to understand, right? When we transform this into a graph, and again, this is a very simple example, right? But if we were to think of, the amount of data we have in our databases, it will be very useful for us to be able to traverse our data as a graph. So if you take a look in here, you're able to see how we have those connections, right? Account 1 connected to account 4, account 4 connected to account 3. And then we want to see that basically account 2 has no connections. And that's really easy to see with graphs visually. So in here, I'm introducing an example, and this is going to be used in our first demonstration, right? We're able to see how we have categories. Categories have subcategories. We also have categories that are connected to products. Products are connected to components. Components have suppliers. But then something that is key in here is that customers are filing tickets against products, right? So even though a product is composed by multiple components, right, the ticket is filed to a product. So let's say that if we had a lot of issues with a product, we would want to be able to map it to a component to be able to identify the supplier and see whether we're having other issues with this supplier supplying us different components, and see if we actually have to change the supplier maybe, or see how we can solve this issue, right? So I know this sounds very complicated, but this is a real world scenario, right? This can happen in the manufacturing industry. And in here, we have our visualization of our graph, right? And how everything is connected in graphs and how we create it from tables, right? And I will be showing this in a demo. So hopefully it becomes a little more clear when we go through the demo. But basically, we're able to perform graph analytics, right, on our data when we basically create a graph from that data, right? So in this example, we have a query, and this is using SQL, right? And then on the other side, on the right side, we actually have the visualization of our graph, right? So if you're able to access your data in the Autonomous database or in the Oracle database, you're able to model your data as a graph and take advantage of analyzing that data as a graph. And in here we have an example of how those queries look, right? So like in this case, we have our graph query in SQL, right? And it's very similar to the SQL structure that we all know. But we have a couple of clauses that are focused on graphs, right? For example, the graph table clause, that's basically to identify which graph we're actually querying. And in the database, you're able to store as many graphs as you want. So that's why we're able to, we need to use that clause to identify which graph we're actually querying. We also have the match clause, and this one is basically the pattern we're looking for. So in this case, we're looking for any components that are connected, or I don't want to use the word components because that's what we have in the match clause, but basically any entity that is connected to components, right? And we're filtering by 1220, that's a component that we're taking a look at. And then we have a columns clause where we're basically explaining or telling the query which columns we want to return. So in this case, we're looking for product ID, product name, and then the component ID, right? And in natural language, this query could be translated to which product is connected to the component with ID 1220. And going back to the Converge database, again, we're able to use vector search, right? Because of the Converge database power and the ability of being able to combine different data structures or data models to get better solutions, right? Or better results, or get more value from our data. And as you can see in here, here's an example of how we do that. And I am going to go over an example where we're combining vector search with graphs in a notebook. But basically, as I said before, you have the Converge database. You're able to combine different data models and get a lot of value from your data, right? And all of this can be done using SQL. So let me go ahead and switch to my notebook. So in here, I'm actually, and I just want to make sure my notebook is being shown right now, right?
No, it's still on the.
Oh,
It's still on
okay.
the. Yeah.
Give me 1 second. Let me go ahead and share my notebook really quick. Maybe I can do an entire screen. Okay, perfect. Are we able to see my notebook?
Yep.
Okay. So here we're in Graph Studio. Graph Studio is basically our environment where we're able to query graphs, even though since we're using SQL, we're able to query graphs everywhere or anywhere we are able to run SQL queries as of right now. But basically I chose Graph Studio because this is, let's say, like the happy place for graph users at Oracle. So let me show you really quick how this graph looks. So I actually have two different graphs because I like testing two different things. But this is the original graph that I actually created for this demo. And if we take a look at the preview, right, we're able to see how we have our categories, referencing back to categories because we have subcategories in categories. Then we have our products connected to customer tickets, products also connected to components and suppliers. So I'm going to go back to my notebook, right? And this is a very similar notebook to Jupyter notebooks in general, but we have different interpreters like Python, SQL, RDF, etc., right? So you're able to run different things in this notebook. But in this case, we're mainly using SQL for this demo. And as you can see in here, we're actually adding a column to our customers table because we're going to map the customer tickets to the components. As of right now, the customer tickets are not mapped to components, they're mapped to products, right? But with graphs, we're able to do this. So if you take a look in here, after creating our sentiment column in our customer ticket, we use generative AI to understand whether the customer ticket is positive, negative, slightly negative, etc., right? And then after we take a look at it and we get the results, we're able to identify that, right? So in here, we're just doing a regular SQL query, and we're just querying the customer tickets table. Then in here, we're actually just taking a look at the products and the sentiment analysis. And again, we're just showing the relationship between our tables and how we created our graph. In here, we have our create property graph statement. So this is the SQL behind how we create our graph. We actually have a modeler, a graph modeler. But in this case, I already created my graph, so I'm just showing you guys how we created this graph behind the covers, right? So we have a vertex table clause, and in here we identify the vertices we want in our graph or our entities. And then we have our edge tables and the connections between them, right? So we have tickets connected to products. We have parent categories connected to categories, so categories, subcategories. We also have categories connected to products, etc., right? So if we take a look at the visualization of our graph, we're able to see how our graph has all of those components, right? And it's really hard to see. Imagine having a very, very big graph, right? I'm just giving you guys like a taste of a smaller graph, but a little more complex, right? Where we have multiple entities and relationships. But in this case, let's say that we wanted to just take a look at one specific category, right? So in here, we're specifying that we want to see electrical systems, and we want to see anything that is connected between 1 to 4 hops from that electrical systems, right? So this means that it will show us 1 hop, 2 hops, 3 hops, or in this case, I have an example for 4 hops, right? So we have a category, electrical systems. We have a subcategory, the steering system. And then we have the product, that is the steering linkage. And then we have the idler arm, which is a component, and then our supplier. So that's where the 4 hops is coming from, right? So this is basically just an idea of showing you how we can interpret data really quick with graphs, right? We're actually not doing anything crazy as of right now. But let's say we wanted to take a look at the sentiment analysis, right, that we did previously with generative AI, and we want to see the products that have slightly negative or negative tickets associated to it, right? So in this case, we're able to identify really quick, okay, transitions gear is the one with the most issues, right? So as a manufacturing, now I need to understand what components are the ones that are giving me the most issues. And if we take a look in here, we're able to identify all of the components. So the transmission gear has multiple components. And what does this mean? That we need to be able to associate that ticket description that is connected to the product to the actual component that is wrong. And this is where vectors and vector distance, vector search has a lot of impact when it comes to our graphs, right? Because we're able to basically create a distance for the ticket vector and the component vector. And then depending on how close that distance is, we're able to map the component to the ticket description. So as you can see in here, we're able to identify that the oil pump has a lot of issues actually. So clearly the oil pump is our issue in that specific product, right? So in this case, we're specifying that we're looking at that specific product and we're able to identify the component, right, connected to that ticket. So now we want to also see, for example, which are the suppliers for our products, right? So in here, you can tell that we have multiple suppliers, right? But since we're only looking at one component specific, which is the one that's giving us the issue, we're able to quickly query the graph and identify that component, the supplier for that component, right? Velocity parts. And then as a manufacturer, maybe I'm interested in seeing what other components are supplied by this supplier, right? And see whether these other components are having issues and whether I have to change my supplier. So basically with graphs, we're able to do that really quick, right? So this was my first demo of using vectors, right, and property graphs. Now we're going to go back to knowledge graphs, and we're going to be talking a little bit about, give me 1 second, I think. Okay. So we're going to be talking about knowledge graphs in general, how they work, and especially how they work with graph rag, right? Because we already covered a little bit about what knowledge graphs are. But basically, graph rag involves vector search, and this helps us match text within a chunk, right? And then the information is often spread around multiple chunks, right? As you can see in here, we have an example where we have a document. And from that document, we try to create a graph, or we create a graph from this document. Why? Because the difficulty comes from the chunks being spread across multiple places in a document, right? When we create the graph from those chunks, we're able to add more context and help with hallucination of documents through a graph, right? So the most important part is we're capturing information from our business, right? That's the RAG part, because LLMs are normally not trained with our information, right? With our domain business, etc. And then with the graphs, we're able to provide a better explainability by using graphs and traversal entities, relationships, etc. So to give you a better understanding of how graph rag works, let's look a little bit under the hood, and we're going to go over this diagram that's going to tell us, the foundational story of how this works. So we're going to start on the left. You have a user prompt, basically a question, plus some prompt context, right? And together, those get combined into what we call an enhanced prompt. So think of this as a system giving the question more structure before going into the actual data. So the enhanced prompt gets fed into the embedded model, and the model converts the text into numerical vectors. This basically means a mathematical representation of the meaning behind the question. And then we run similarity search against our vector stored to find the chunks. So basically, this is the data stored in our database, and we vectorized it, right? To be able to get that vector entity to, or that vector value, right? Just like I was saying, numerical vector, right? That is the mathematical representation. And then from that, we are able to find semantical closed basically properties or data points that are very similar to the question, right? So normally that's where vectors and RAG take place, right? That's basically the basic RAG, right? But since we're talking about graph RAG, we want to add the graph part to it. So normally, in a basic RAG pipeline, you'd take those vector matches and immediately stuff them into the prompt, and then you're done. But in this case, those vector ID matches get passed through the knowledge graph to pull the surrounding context. So this means the connections, the entities, related facts, and basically the broader information in our network. And then we re-rank if needed and assemble it again for the full context, and then that context gets injected into the augmented prompt. So now we have a much richer answer compared to the original one, right? And that's what we feed to the LLM. So the result is going to be a response that grounds not just in semantical similar text, but also in structural relationships between the facts. So the LLM isn't just guessing the connections, because that graph is already in our database, right? So the structure is already there. And that's where we get the response. Okay, so I'm gonna go over an example of how we use basically graphs or knowledge graphs in graph rag, right? And just to give a little bit of context, this is a story from Sherlock Holmes, right? It's the blue carbuncle story. Maybe not everyone is familiar with it, but It's a jewel that gets stolen from a hotel, and Sherlock Holmes is trying to identify who stole the jewel, of course, very important. And basically, at first glance, let's say if a human wasn't reading this text, they would assume that the first accused person was the one that stole the jewel. But in reality, if you actually read the text, you'll be able to identify the actual culprit or the actual person that stole the jewel. So let's go ahead and see how graphs are used to be able to identify the real person that stole the jewel. So we're going to begin by creating a table to store our fragments. And I just want to point out that this is done all in SQL. This first step is being done in SQL Developer. So then we're using the vector API to split the source text into chunks. And this is the chunking step of the RAG pipeline, right? The regular step. Next, we are going to call OCI Generative AI with a structured prompt to extract entities and relationships from those chunks. And to help the model get better returns, we're going to give it an example of a prompt or of extraction, right? Like a structure. So in this case, I want to say, for example, I want the structure to be Ramu works for Oracle, right? So entity, relationship, entity. And this gives the LLM a clear template to follow. And then the results come back as JSON. So we then parse the JSON to extract the entities and relationships and store them in tables, right? So in here, we're storing it in a table. And here's the output. You can see that Holmes is an entity that has interacted with Peterson. And then we also have James Ryder that works at the Hotel Cosmopolitan, and so on. So now that we have this structured data, we can build a graph from it. And we're going to go ahead and build a graph in this query, right? And as you can see, it's a very similar query to the one we used to create our manufacturing graph. And then once the graph is created, we're going to combine it with vector search to enable graph RAG, right? So basically, this gives us the powerful relationship and entities that can help us as a starting point. And then we can ask the LLM who stole the jewel. And the model returns that the Hotel Cosmopolitan is a key location, right? So now that we're done getting a little bit of context, right, we can go back to Graph Studio and try to understand our data visually, right? So again, Graph Studio, that's the same place we did our previous demo. And we're going to start with a very simple query to see all of the entities and their connections. So when this is done running, okay, it's going to show basically a representation of the entire story visually. And you can immediately see how Holmes has the most connections. He's the center, right, of this story. And then we're also looking at which entities are connected both to the jewel, and to the Hotel Cosmopolitan. And here we're looking at the specific pattern for that. And when we run this, we're able to identify the hotel, the victim on the left side, and then the jewel and the actual culprit, the person that actually stole the jewel. So in here, we're actually going to filter specifically by Ryder and the Hotel Cosmopolitan. And you can notice that Ryder is linked to several fragments or nodes, and those fragments are exactly what we pass to the LLM to answer the question of who stole the jewel, right? So we have to understand that this is basically all of the chunks, right? All of the relationships that were created from chunks. So this is what the LLM would use to answer that question. And then if we wanted to take a quick look also to understand a little bit more the story, we can also run the query to show all of the entities that are connected to James Ryder and also to John Horner, which was the person that was blamed without being the right person, right? And we see how James Ryder has a lot more connections compared to the person that was not the actual person that stole the jewel. So, and lastly, we go ahead and this is basically the query of John Horner, which has a lot less chunks associated with him. And then after that, we can also take a look at the blue carbuncular, which is the jewel, right, that was stolen. And as you can see, it's connected to Sherlock Holmes. And of course, it has a lot of connections, right? Because it's the main character in our story. So we're able to deduce a lot just from visualizing our data as a graph, but we're also understanding which relationships we're feeding the LLM to answer the question correctly, right? And we get a lot of context and a lot of information just by using graphs with RAG. So this is the end of my presentation or my podcast, right? My session on knowledge graphs. And let's say that you want to learn a little bit more about graphs. We have Oracle Live Labs. Not sure if you guys are familiar with Oracle Live Labs, but it's an amazing way for you to get started on any Oracle technology. It actually gives you a free environment where you're able to test whatever you want. You don't have to worry about breaking your personal environment because it goes away. So amazing place to get started. We also have blogs and a YouTube channel where we post things about new releases, how to use cases, etc. So definitely take a look at that if you're interested in Oracle graphs or spatial. And if you have any questions, you can always, connect with me on LinkedIn. But this is like the end of my PowerPoint presentation. So I don't know if you have any questions in specific.
Yeah, that was a really interesting topic. Like, I have two questions. The first one is like the relationship graph you showed on the earlier slides, like looked very prompt friendly for the LLMs, like a single entity, like a customer, and also this like Sherlock Holmes example where it moves around. Can I expose this to an AI agent, like with a tool or maybe some built-in things, where like I can say, okay, here's the customer, go figure out for the answers.
Yeah, actually you can. So one of the big things we have at Oracle right now is Select AI. So you can ask questions in natural language. And since we're using SQL, and you feed it a graph, it'll be able to answer any questions about the graph. There's a lot of LLMs out there right now that are also familiar with SQL property graphs, which is, the language that we use at Oracle. And they're able to do a pretty decent job at, creating that SQL, getting the answer, etc. So if you were to use the Oracle database, I would definitely recommend Select AI. But you should be able to use it with agents.
Yeah, that's good to hear, Sid. The other question I had was, especially also this is also related to the AI part. So I know the OCI functions are getting very popular on this ETL jobs and things because it was also talked on the previous episodes in this channel. So can I use this graphs like in a visual way in this OCI graphs, like a building part, or can I implement it as a step to my OCI flow?
Yeah, of course. So it really depends. So we're integrated in the database side, right? But you're able to integrate this even in your own applications, right? We have a client library where if you create your own application, you're able to implement the visualization side of it. We have Apex. I don't know if you've ever heard of that, but it's a way for us to build low code applications, and you're also able to use the visualization side for that. So yeah, I think it's pretty adaptable in the OCI world, specifically if you're using the Oracle database.
Yeah, that was all my questions. So thank you everyone for today's episode. Also, thank you Ramu for joining us. So, if you want to be a speaker on the next episode, please fill the form on the below, and we will also share the links of the Ramu to on the description. So, take care everyone. Bye.
Bye.